Okay. So let's do another one. Again, we've got our acid, base, salt flow chart. And the question is, what is the, this is if you get a what is the pH of question. And so let's guess the question, what is the pH of 0.12 molarity solution of sodium borate? The first thing you say is this an acid, a base, or a salt? Not an acid. Acids all have name, blah, blah, acid. Doesn't look like any of our bases. We could check our list of strong bases. We could check our KB table for our list of weak bases, see if it's on there. It's not, but this is a salt. It has to be a salt. That's the only one left. How do I recognize it's a salt? A salt is an ionic compound that is made up of ions. And each of the ions, the cation and the anion, have their own name. And the name of the ionic compound is the name of the two ions. If you need to go back and review nomenclature from Gen Chem 1, we did a lot of this, and there are videos on that on my YouTube channel, the Shea Bean YouTube channel, of nomenclature, naming ionic compounds. Dig them out, give me a holler on the discussion board, I'll post them for you. But sodium borate fits the pattern of this is an ionic compound. And as you may recall from Gen Chem 1, still the case, if I have a soluble ionic compound, we're calling that a salt, the first thing you do, that happens when you put it in water, is it ionizes 100% as long as it's soluble. It breaks apart to give you ions. It forms 100% ions. So let's walk through the ions that sodium borate form. I could Google it. You absolutely have that prerogative, but you kind of have to know what you're looking at. Now you should know what the sodium ion looks like without Googling it. You may not know what the borate ion looks like without Googling it, but you actually have a way to see it without having to Google something that's not allowed to be Googled on an exam. Quizzes you can Google, you got to watch your time. Quizzes are open book, open notes, you just can't have another person. Exams, you're kind of restricted to what you can look at, so let's figure out how to see this. First of all, sodium ion, if you don't know right off the top of your head that's Na+, you need to go back and review that from Gen Chem 1. The borate ion, now that one's a little trickier, but if we look at our tables, and I'm going to see if I can do this. If we look at our tables, there we go. I think you're looking at it. I wouldn't swear to it. We'll see when I look at the recording. There is something called boric acid, which sounds a lot like a borate ion. Since those sound so similar, you may recall from Module 6, maybe Module 5, that a conjugate acid-base pair are very, very similar, except for the conjugate acid has an extra H+ ion. The conjugate base is missing that H+ ion. Therefore, the names of the conjugate acid-base pair are very similar. The chloride ion and hydrogen chloride or hydrochloric acid. So the names of the acetate ion and acetic acid. The names of a conjugate acid-base pair are very similar. So the borate ion sounds very similar to boric acid, which is in our table. You can look it up. Boric acid has the formula H3BO3. It has a Ka value in our table of 5.4 times 10 to the minus 10. I could draw out as the Lewis structure because it's given in our Ka table, but I'm not going to. But the borate ion is what you get when boric acid acts like an acid and donates its H+. And so boric acid is H2BO3. If it donates an H+, his charge becomes negative. There's the borate ion with a -1. So the formula for sodium borate, he's made up of the sodium ion and the borate ion. He is NaH2BO3. That's what you'll see if you Google the formula for sodium borate. The letters may be in a slightly different order, but it's sodium, 2 hydrogens, a boron, and 3 oxygens. But that's how I figure out what the borate ion is, and how is it important to this discussion? Well, it's important to this discussion because when I dissolve sodium borate in water, I no longer have sodium borate. I have sodium ions and I have borate ions. And now the question becomes, what's the pH of a solution where I've got sodium ions and borate ions floating around? So up here, when I've got my salt, the first thing I have to do is I have to break it up 100% into ions. And for each of those ions, I have to decide, is that an acidic ion, is that a basic ion, or is that a neutral ion? If I have neutral ions, they don't change the pH from pH 7. Acidic and basic ions are going to contribute to my pH, and I'll have to work them as an acidic or basic problem. And how do I work them as an acidic or basic problem? I know how to do that. If I have a weak acid, that's how I work the problem. If I have a weak base, that's how I work the problem. So once I decide if my ion is acidic, basic, or neutral, I look to see if I have an acidic ion, I work it like a weak acid problem. If I have a basic ion, I work it like a weak base problem. If I have a neutral ion, I ignore it. So let's do the neutral ones first. The neutral ions are the ones that come from or are conjugates of strong acids and bases. Your lecture videos talk about the parent acid and base used to produce that. So sodium hydroxide would be used to produce sodium ion. Sodium ion comes from NaOH. NaOH is a strong base. Therefore, the sodium ion is neutral, and I can ignore it. Every time you have a salt with sodium ion, you can ignore the sodium ion, it's neutral. Every time you have a salt with a lithium ion, you can ignore the lithium ion, it's neutral. Every time you have a salt with any of the cations that come from strong bases, you can ignore them because they're neutral. Any of the anions that come from strong acids are neutral. So hydrochloric acid is a strong acid, therefore the chloride ion is neutral, and so on. And we'll see some of those. But the borate ion does not come from a strong acid. It comes from a weak acid. And we learned back in the first module for acids and bases, if something comes from a weak acid, or if it's the conjugate of a weak acid, therefore it is a weak base. So I have dissolved this salt in water, and I have produced a weakly basic ion, a basic ion. I have taken my soluble salt, I have split it up 100% into ions, and I have labeled the two ions. One of them is neutral and one of them is basic. And if I have a basic ion, it will be a weak base. And how do I work a weak base problem? I write an equilibrium reaction. I have a KB, I have an ice table, I solve for X. The X gives me the OH minus, and from the POH I get the pH. So let's work that weak base problem with the borate ion, H2BO3 negative. Now at this point, we can start using abbreviations. You can actually write your equilibrium reaction with this species. What does a base do? This is a base, a weak base. It reacts with water to accept a proton, so he goes back to his conjugate acid. We saw him earlier. and OH minus. So I can actually write out that equilibrium reaction, or I can just do a generic equilibrium reaction. A generic equilibrium reaction is where I have a base. This happens to have a minus charge, which I can either add or not. That part doesn't matter. Plus water. He's going to become HB as he accepts a proton, and I'll generate the OH minus. Or I could use, again, we're just symbolizing this. Let me scroll back up. I can just use the generic reaction. I could just start with B plus H2O yields equilibrium with BH plus OH minus. It doesn't matter how I symbolize it. The important thing is that I see that I've got an OH minus here, and I recognize that that's that basic ion that I'm starting with. And so I set up an ice table. Let me go back to my problem because I've already forgotten. It is a 0.12 molarity solution of that salt. Since it's a 1-to-1 dissociation, that means that the borate ion will be 0.12 molarity, 0 and 0, minus X, plus X and plus X. And now I need a Kb value. If you look at your Kb table, there is no Kb for the borate ion, but we saw earlier on the Ka table, there was a Ka value for boric acid, and you might recall that Ka times Kb for a conjugate acid-base pair equals 10 to the minus 14, as long as you have a conjugate acid-base pair. So Kb, what is the Kb? It's 1 times 10 to the minus 14 divided by the Ka for boric acid. And I'm going to get that from the table. So it's 1 times 10 to the minus 14 divided by 5.4 times 10 to the minus 10. That comes from the table. So now I'm going to set up my quadratic equation. I like just doing this. I don't like punching this into the calculator yet because I can't round. You cannot round in the middle. You'll get the wrong answer. We are back at, can I use the approximation? I always try it first. So let me use the approximation. Again, I don't like punching this in until I'm ready to punch everything in. I'm not going to show you the algebra. I'm going to solve for X. All right. If you are punching it in, you're going to get something like 1.85 ... times 10 to the minus 5 for this guy, for this Kb. I'm not pausing on my calculator. I'm leaving all the digits there. I'm just now going to multiply by 0.12 and then take the square root. And when I do that, X is equal to 1.4907 ... times 10 to the minus 3. Man, I just keep picking the problems where the approximation is so close. I'm not sure if the approximation worked here, but I am going to try it first. If this is X, remember X is my OH minus. That means my POH, I'm going to store this, is 2.83, and my pH is 11.17. Again, quick check. That is a basic pH. We had a basic salt. Good. I didn't miss a step. If we do the exact method, again, plug into a quadratic equation solver, use the approximation method that I'm getting ready to do that. It is going to take me a minute. All right. There we go. If we do it exactly, we get 1.481 ... times 10 to the minus 3. You can kind of see how close they were. Using the approximation, we got 1.49 times 10 to the minus 3. Without the approximation, we got 1.48. They're pretty darn close, so we're probably going to get about the same answer. So with that being my X, my POH is 2.83. Look, it's exactly the same. So the approximation method worked fine this time, 11.17. So that's how you find the pH of a salt. In this case, we had a basic salt.